So hi again, this is question 5 for set 2 of 2507. On this question we have to assume an ideal op-amp for the following circuit, and then we need to find V out here at the output. Okay? So, and what's the input impedance R1? So it's the input impedance seen from the input source. So if you remember, for an ideal op-amp, there is no current entering those nodes here. So this current here and this current here, they are all 0, right? So from an ideal op-amp, we know that I minus equals to I plus equals to 0 amperes. There is no current, right? But we also know, because of the infinite open loop gain, that the voltage at the inverting input is equals to the voltage at the non-inverting input is equals to the voltage at the inverting input. So if we find out one of those, V plus or V minus, we actually know the other, okay? So in order to determine V out here, let's first find the voltage at the non-inverting input, so the voltage at this node here. Now if you look at this circuit, we know that there's no current entering the non-inverting port, right? So this circuit here at the non-inverting input, it becomes just a voltage divider, right? So the voltage V plus is actually the voltage across this 8K ohm resistor. So if we apply a voltage divider here, we find out that V plus, right? So let's call it first step. We know that V plus is going to be equals to those 5 millivolts times the 8K divided by 8K plus the 16K. And this is equals to 1.67 millivolts, okay? So if we know V plus, we know V minus. So now we know the voltage at this node here. Let me use a different color. So the voltage at this node here is the same, 1.67 millivolts, okay? Now if we, for the second part, so if we apply KCL at this node here, this blue node that I have, we know that V minus 0 volts divided by 1K, right, is equals, plus V minus V out divided by 9K ohm. That's equals to 0, because those two currents that we have, so one current here, another current here, those are the two currents that we have flowing through that node, right? So this is the equation that we get. Now if we substitute the value of, because we know that V minus is equals, so I'll put a comma here, is equals to V plus, okay? If we substitute this into this equation here, we get that V plus times 1 over 1K plus 1 over 9K, right, is equals to V out over 9K. And that's the same as V out equals to V plus times 1 plus 9, which implies that V out is actually 10 times V plus. So this is a non-inverting amplifier, right? So if we calculate the value, so if we substitute here V plus as 1.67 millivolts that we have up there, we get that V out is actually 16.7 millivolts. So that's the answer for the second part. That's actually the answer for V out. Now, what's the input impedance? So for the input impedance, let me just remove some notations here. So for the input impedance, we know that there's no current flowing here, right? It's zero from the ideal op amp. So to define the input impedance, we know that the definition of the input impedance is equals to Vi, I call it Vi, divided by I1. And I1 is this current that is flowing here, right? And the voltage, Vi, is this voltage at this node here. So in our case, this Vi is exactly 5 millivolts. Now what's the current? I1. So because there's no current here, right, this current I plus is 0, right? So there's only a current I1 that's flowing in series here between this 16K and 8K. So we can calculate I1 as those same 5 millivolts divided by the 16K plus the 8K. And this gives us a current that is 20.83 microamperes. Right? So the input resistance is going to be equal to those 5 millivolts divided by those 20.83 microamperes. And that's exactly 24 kilo ohms, right? Which is the same as summing this 16K plus this 8K here. Because if you look at the circuit at this terminal here, the non-inverting terminal, it's basically, we have just this circuit here. So it's a voltage source, right? A resistor here, another resistor here. And that's the positive terminal, the non-inverting terminal of the op amp. But because there is no current flowing here, there's no current flowing here. The impedance seen from the voltage source, or the input impedance seen from this terminal here, is just the sum of the 16K here plus the 8K there, which is those 24 kilo ohms.